Okay. All right. We are recording the meeting. This is going to be posted to our YouTube channel so other people can see it that we're not able to. So I hope that everybody's doing well and COVID-free. I know we've had quite a few cases here. And that's sort of why we're still doing virtual meetings. At this point, I just think it's a safer thing to do. It makes a lot of sense to me. So has everybody been reprogramming their DEF systems? I think there's been quite an issue with the DEF systems where we can't get the parts to the sending unit. And one of the things that I just remembered is the decal here that goes on all the buses. Leonard has been taking care of ours, and they're reprogramming it so that it doesn't derate. I know it's kind of old news, but I imagine everybody here is up against that and having that done. And during this, I'm going to start out with this. We are looking for a treasurer. We need to find somebody to take the treasurer position. Dave Crom can no longer do it. I currently have the material, so we do need somebody to step up and take that position. So if you know of anybody or you think about it, just send me an email, let me know, and we'll move forward with that. I also want to thank everybody for the replies and stuff. Like when Bethlehem was looking for some information on fuel, you know, everybody pitches in and helps everybody out. That's sort of what the organization is for. We're all going through these times, and the more we can all get together, the better. So our last meeting was held on November 17th, and Cody Shamrock presented on disc brakes. And some of the things that we got from that was the disc brakes. It's funny that we were just discussing disc brakes here a little while ago. Better response time, less brake fade as they heat up. So drum brakes tend to fade. Disc brakes, they actually even get a little bit better. More of the components are sealed, so you don't have exposed parts like you do on the drum brakes. They say that it's the same kit for the front or the rear, which is good. It keeps your inventory simple. They said do not reuse any of the old parts. So if you're going to do a brake job on the disc brakes and it just needs pads, put all new hardware, everything that comes in the kit. Don't just change the pads. About 2 or 3 pad replacements, and it's going to need a rotor. It's got little lines that when they line up, the brake pads need to be replaced. So that's kind of neat. It's a very simple system. It's a 10 millimeter box wrench. It's all that's needed for adjusting. You tighten the way you adjust it is you tighten it up until the pads hit the rotor. Then you back it off 3 clicks and you're good to go. So that was just a few of the highlights from the meeting. I thought it was a really informative meeting. And today's presentation will be on high voltage systems and the safety that is needed to work on them. Our presenter is going to be Roger Harrod with Matthews Buses. And that being said, I'm going to hand the meeting over to you, Roger.
All right, let's see if we can get my screen up here. Okay, let's see if we can change it over. Do you see my screen?
Yes.
Thank you. All right, I want to introduce you to Jouley. This is the new Thomas C2 electric bus, and I've always had somewhat of a laugh about these new names that you come up with for these different products. And well, there is a reason behind it. Jouley is an international system of electrical energy. And I guess it's an appropriate name. But let's go on and take a look at this. First off, Thomas has been building electric vehicles since our beginning. We started off building streetcars. The big difference there is, of course, there were no batteries. We did build some military stuff during World War II. This is kind of an interesting bus over here on the right side. This bus was a full electric bus. You can tell by the shape of it, it's a rather older unit, but the interesting part was it was so heavy with all the batteries, you couldn't legally carry any passengers. It shot in the dark anyways. We did build some prototypes back in the 90s, but today's product is much more in tune to the electrification, and the real advantage here is that Daimler has committed it to the EV market. You see 3 of the products we're currently building for the EV. We have the electric seat, the electric Cascadia. That, by the way, is a 700 volt system. That's a big package. And the EM2 and, of course, the Jouley package are very similar in their design and size. Basic specifications on it. Advertised range is 138 miles on a full charge of batteries. We do have a 226 kilowatt total battery capacity on board, which is a large battery pack. Our horsepower is a little lower than some of the other products out there in the market. We're only running 295 horse, but we run that through a 2-speed transmission. Our major co-builder here, Proterra, who has built the electric system for this chassis, have had a lot of good luck with the smaller engines and the 2-speed transmission, giving them the low-end torque we need and the high-end efficiency we need to reduce the load on the batteries. One thing we've also done with the Jouley package is we've adopted a 100% thermal regulated battery. Now, anyone who's gone out in the wintertime with a cell phone in an outside pocket knows what we're talking about here. If you get a battery of these types cold, they lose charge. And we are 100% thermally regulated to maintain the charge in the batteries. And we're only a DC fast charge system, which we'll talk about later. Here's a basic chassis. It looks a lot different than what we've got, but I'm going to simplify this somewhat. Number one, our air system is entirely behind the rear axle. Why? Because there's nothing else back there, and it's a nice, convenient place to get to. The center of the bus contains the powertrain and batteries, both the low voltage and high voltage batteries, and the control system is in the front of the bus. This system does have the ability to add cabin air conditioning. That's an optional package that's left mounted for the compressor. The condenser is a rooftop compressor. Now, this is a high voltage DC. The batteries are DC, the charging system's DC. And all of this DC voltage initially goes through what's called a high voltage junction box, which is up here on the front right corner of the bus. The charge connector goes through here. The battery cables initialize from here. And we do have a high voltage disconnect switch here as a safety item. If necessary, we can knock the system off. Now, this system then distributes power to the telematic charge management system. We have an air conditioning compressor on the firewall, 400 volts DC. I'll show you where that's used a little bit later. We also have 2 heaters under the chassis. Now, keep in mind, the chassis is the high voltage side of a school bus. The body is still 12 volt. In fact, the body is exactly the same body that we use in our other production C2s. There is no difference in it whatsoever. But we obviously are going to need 12 volt. We don't have an engine with an alternator. So we have a 14 volt inverter. This is converting high voltage DC to low voltage DC to charge the batteries. This is at 200 amps. And this charges our 2 low voltage batteries, and there is a low voltage battery cutoff switch here as well. Now, this is DC, but we do need AC when we're talking about motors. The problem with a motor is if you want to change the speed of a motor, you have to change the voltage with DC. With AC, I just have to change the frequency. So I have a variable frequency drive also in the front, which is converting high voltage DC to high voltage AC. This powers the power steering motor and pump, and the air compressor motor and pump at the rear of the chassis. Here you see the high voltage lines, the orange lines, and the black coolant lines that run above our batteries. There are two batteries here, one stacked on top of the other. It's mounted between here and the body, which is going to sit on top of the frame. Now, obviously, once the body is seated on top of here, you have no access to this area whatsoever. So to reduce the chance you'd ever need to get in here, we have added additional frame supports, securing these hoses and cables so they aren't moving around doing nasty things. And the other thing that's been done here is there's no connections anywhere inside of this captured area that you would ever have to get to. Everything here is a continuous line or hose. The battery packs, again, we're running two 13 kilowatt hour battery packs, one on top of the other, giving us a total capacity of 226 kilowatt hours. You can't use all of this. A lithium ion battery, in fact, no battery can be completely discharged and recharged over and over again without really destroying the battery pack. So we're limited to only using 90% of the total, around 204 kilowatt hours. That can be relayed out to the available energy we have, which will produce up to 138-mile range. Now, please note, two battery cables from each of these batteries, both the positive and negative. The reason this is important is the high voltage system does not use chassis ground. Everything is individually ground, reducing the chance of ever having a short to ground with a high voltage system. Here we see the power pack, the powertrain system, the inverter, the traction motor, the transmission mounted behind it. And we see a lot of cables here. And again, these orange cables. The top two cables here, in fact, are the ones that go from the batteries, the DC side of the inverter, and they go up and power the high voltage junction box. This is also how the charge connector, the charge plug, charging the vehicle, sends voltage back into the assembly and charges the batteries. The next four cables are the battery cables themselves going in the front of the inverter. We've got one more cable, which is actually a double cable. This is high voltage AC from the variable frequency drive to the air compressor. And you can see how it snakes through here and continues on to the rear of the bus. Now at the back, we've got three more cables. These are from the AC side of the inverter. We need AC voltage for the traction motor. This is powering the traction motor. Now controlling all of this, we have a powertrain ECU. This is a 12-volt module. It ties into all of these. It also ties into the throttle. It ties into the shift selector and ties into the brake system to control this properly. Now, reverse is, I want to pick up reverse at this point. Reverse, we do not use the transmission to go into a reverse ratio. We just reverse the traction motor. We also reduce the torque. We limit the speed to 8 miles per hour, and the throttle response is reduced in reverse, meaning the driver's going to have to push the pedal further in reverse as a safety issue. Here we see the air system at the rear of the chassis. Here is the high voltage AC lines coming to the motor and our new rotary compressor. Now this compressor and all the air components are here mounted behind the rear axle. The only thing missing from this slide is the accessory air tank, which in New York State we would be using. This particular chassis did not have one on it. Now, here's the interesting part, really different part of an electric bus. On an internal combustion engine, we've got a one big cooling system, which we try to get everything done from. On an electric bus, we have separate cooling systems dependent upon the needs. This is the power electronics loop. This uses the radiator. All the items here that are red, electrical and mechanical, are creating heat, which we need to control. All of this, we have coolant circulating by an electric water pump to the radiator to dissipate the heat, and if necessary, there's actually a couple electric fans bolted to the inside of this radiator to reduce the temperature. Now, keep in mind, there's not a lot of heat here. In fact, there is not enough heat here to heat the cabin with. So it's not used for it. This is a solely closed loop system just to maintain the temperature on these components. The second cooling system is the transmission. It has its own air-to-oil cooler on the right channel. Now, number 3, we have the battery thermal management system. We are 100% thermally managed, meaning what? Lithium-ion batteries like to run at 70 degrees. If they're not at 70, they're not happy. So what we have is we have a cooling system in the battery packs, and in the wintertime, it's connected to a heater. We have an electric heater underneath the bus, orange cables, 400 volts DC, that will heat the water to the appropriate temperature to maintain the batteries when it's cold. Now, when it's hot out, we have a reverse situation. We have to keep the batteries from overheating. In that case, again, this coolant is circulated by its own electric water pump. We have an air conditioning compressor mounted on the firewall, sending refrigerant to a chiller on the right frame rail. That chiller chills the coolant passing through this system, and we will cool the batteries down to the appropriate temperature, maintaining that 100% electrical charge at all times. Now, one of the nice advantages of this system is, since this compressor is mounted right here on the firewall, and here's the dash, we've given every driver of an EC2 dash air conditioning. Cabin air is an option, but dash air is standard. Now we have to heat the cabin. You have to realize we don't have an engine here producing all kinds of heat that we have to get rid of. And in fact, the system's really kind of backwards. In the summertime, the engine provides the most heat in the coolant. We have over 205 degrees. In the wintertime, we're lucky if we get 170 degrees. And on those coldest days, we're stretching for that. And of course, that's going to affect the operation of the engine and the emission systems and everything else. Well, with an electric vehicle, you don't have an engine. Well, we still have to heat the cabin. And we do that with the cabin heater. Here's the battery heater we talked about a minute ago. Here's the cabin heater. The cabin heater has a circulation system through all of the heater cores. It has its own electric water pump and is controlled by this switch on the dash. This switch, by the way, on the blue side is the cab or the dash air conditioning system for the driver. On this side, it's the cabin heat. So he would rotate this switch as necessary to give himself either air conditioning in the summer months or heat in the colder months. Now, keep in mind, the fans are still on every one of these cabin heaters. The Froster, everything has a 12-volt fan on it, which is controlled by the same switches. We didn't change the body. The body's the same, so the same switches are there to control the rate of airflow through all the heaters. The big difference here in the summer months, I don't have to turn off the valves to keep the cabin from overheating from the coolant. I can just turn the switch off. Now, the other thing to keep in mind is the fan switches don't control the heater. The heater doesn't control the fans. In the past, if the driver had enough heat, he would just turn his fans down. In this system, he would turn the heat down. It's very important when there's not requiring heat that the heater switch be rotated to the blue area. What's powering this? This is the same battery pack powering this that's powering the wheels of the vehicle. And this will affect the driving range of the vehicle. Though this is being used right now in several buses up in Alaska, and it works fine. Now, each Jouley comes equipped with the new Bendix and Telepark brake system. This is an electric switch versus the old pneumatic switch. It's a lot easier to use, but obviously you have to have the ignition on to engage it. It's a 12-volt switch. The neat part of this is it's tied into the entrance door. If the entrance door is open when this brake is applied, it will not release until you close the door. More importantly, if the parking brake isn't set, say the driver has stopped, he has forgotten something, he pops the entrance door off and runs out of the bus without turning on the brake. If the if the vehicle senses movement, the IntelliPark will set all by itself. This is a neat package. Now, in mind, I had to really talk about that because we're going to talk about it here. Starting the vehicle, this is an electric vehicle. How does it start differently? Well, you turn the key to the on position, and you're going to hear whistles and bells and electric pumps and fans and all kinds of stuff, and you do have to wait for that to complete. That's going to take a second or two. While you're here waiting, you got the ignition on. Let's engage the parking brake if it hasn't been set. All right. Turn the key to the start position and then release it. And this could take, again, some additional time. What are we waiting for? We're waiting for the high voltage enabled indicator. That's this guy right here. That comes on right here on the dash, and that tells the driver that the high voltage has been enabled and we are ready to go. We do, however, ask him to check the driver display at this time on the dash to see if there's any faults that should be checked before we leave. Then apply the service brakes, close the entrance door, and release the parking brake. Select driver reverse on the drive selector, and he's off for the day. Now, at the end of the day, put the transmission in neutral, set the parking brake, turn off the key. There is no magic. Now, the dash on this one is quite a bit different, and we are using a different vendor here. This is the Amatec dash. We've used this on the propane units. It has some real nice advantages. First, it has a much better driver message area down below here, but the big change, obviously, is we don't have a tachometer here anymore. The fuel gauge is gone, but we now have a state of charge gauge here at the top, full, half, empty. There's the most important light right there, by the way. There's the high voltage enabled indicator. You can see where it's located here on the dash. And that's the one we're going to start with, the driver's going to need to get started with. Now, we got a whole bunch of other ones here that have been changed. Obviously, we've seen number one already. We've seen the battery state of charge. We've got a whole bunch of new icons, and to make it a bit easier to understand what these things are and to see them better, I've reproduced them up here at the top of the screen, and it would make it easier to go through these. Number 10 is charger plugged in, and it's located over here on the left side. The reason for that being there is, let's say the driver opens the door, gets up in his seat, puts the key in, and tries to start the bus, and it won't start. If this light is illuminated, he has forgotten to remove the charger plug. The bus cannot run with the charger still plugged in. He has to turn the key off, go outside the bus, remove the charger appropriately, put it back into the charger, get back in, and start it again. Now, the next one here, 4, 11, and 12, this represents a motor, and it has an exclamation point on it. Number 4 is a temperature gauge. That's the motor temperature. 11 and 12, one's yellow, one's red. One's a caution, one's a warning. 11 is a minor fault with the motor. That's the yellow one. The red one is a critical fault with the motor. The next icon is a battery pack, again with an exclamation point on it. Number 3, battery temperature. 14 and 15, one's red, one's yellow. The yellow one is a warning for low state of charge. The red one is a critical warning, very low state of charge. Number 13, right over here next to the vehicle high voltage enabled indicator, is a circle with the silhouette of a turtle in it. And that turtle shows that you are in limp mode. The unit has been greatly derated. The state of charge is 8% or less. 8%, by the way, on a good day might be 10 miles. That's not a very good thing to be into. And the last one that's new here is number 20. Number 20 is a triangle with a lightning bolt in it. A lightning bolt is about the high voltage interlock loop. This is a 12-volt system which monitors the state of the high voltage connectors. If anything is array with those high voltage connectors and there's a chance that one might become loosened or short, that system will immediately shut the system down. If the light comes on, basically it tells you that something has been found that should be rectified. We should be getting in touch with someone who can repair it properly. Now, the message center, right in here, we have a lot more capability with this dash than we did with the old one. It can give us English warnings. The only one that they have identified with this chassis that should be of interest is the words low voltage. Low voltage has nothing to do with the 400-volt system. It is a 12-volt system warning. There's no specific fault that they have identified that will cause this, but what they're looking for here is something has severely reduced the voltage in the 12-volt system. There's been a draw or it's been a battery problem. There's something wrong with the 12-volt system. If you lose the 12-volt system, the 400-volt system goes out of commission immediately. And this goes on at 11.9 volts. The recommendation they have on this is if you're driving the vehicle at the time, to pull to the side of the road, turn off all the 12-volt systems you can, except the ignition switch. Leaving the ignition switch on allows the 400-volt system through the 14-volt inverter to recharge the 12-volt batteries. All right. Regenerative braking, or does the electric vehicle have an engine brake? Well, it doesn't have an engine. It doesn't have an engine brake, but we do have the ability with regenerative braking to use the rotation of the drive shaft to charge the battery, and will give us a braking effect. And yes, that is in effect an engine brake for an EV. It works as soon as you take your foot off the accelerator. In fact, you're going to find in most cases you aren't going to be using the service brakes. Now, if you use the service brakes with it, it'll max out to its maximum position at 10% throttle pedal. Full state of charge, it doesn't work. If you think about this, we're using the output shaft to drive the motor, turning it into an inverter, charging the battery. Well, if the battery is at 100% state of charge, it can't accept any power, so RB will not work. You might get a comment from someone who just gets in the vehicle after it's come off the charger and says, well, RB doesn't work. That's right. It can't work until you've used some of the energy that's in the battery, and it will work fine. If there's an ABS event, it will deactivate, the same as all other systems will. You can put a temporary switch on the dash, a temporary deactivation switch, a momentary switch, which will turn it off for a few moments here. It will engage immediately when you come to a complete stop. This is much like traction control. You can turn it off temporarily, but it will re-engage automatically. Peak power on the braking system is 220, continuous 107. And we do get more regenerative braking in the low range than we do in the drive range, because in the low range, we're turning the motor faster. It's able to capture more energy. And lastly, there are some magic calculations that go through here to give you a very consistent deceleration rate on this. Now, this slide we've used for years, and it's one, we want our drivers all to be star drivers to get the most miles with the least amount of energy, and to start slow and transition smoothly and all of this stuff. The only thing we've added to it is one line, and regenerate. Because now we can allow the unit to help slow down and make this a more efficient vehicle. Now, safety issues. The body is the same body that we're using on the production internal combustion unit C2s. There's no difference. So every safety item that was available on the C2 body is available on the EC2 body. There's no changes or differences here. Obviously, the chassis is completely different. We have a whole bunch of safety interlock, hardware interlocks, software features, isolation monitoring systems, safety by mechanical function design, multiple shutoff switches, and lots of high voltage labeling. But I have to back up and say the easiest way to think about this is to think orange. Now, I'm certain we have some hunters within the group listening today. When you're in the woods, you've got your orange vest on. And the orange vest isn't to make you look more handsome. It's to identify that you're not a deer. Please don't shoot me. Well, the same thing here. We didn't color our high voltage connectors and cables orange to make them look pretty. We did them so we can see them. You can identify with them. If it's orange and you're not qualified, you can't touch. And that's really the most important safety thing you have to keep in mind with high voltage units. Maintenance. We should see less maintenance on an EV. We are seeing less maintenance. Why? Well, number one is we have no internal combustion engine, and all the related garbage that was on it. We have no belt-driven accessories. Thank you. We have no emission components to maintain. No DEF tanks. And regenerative braking should reduce the wear and tear on the brakes considerably. This should be a much easier unit to take care of. Now, battery range is let's explain the battery range. Battery range is you take how much energy you've got in the batteries. This is how much I have available. And then you use what's called the vehicle efficiency. Vehicle efficiency was calculated by taking an average bus with an average load, with the average driver, with the average optimal conditions and all of that stuff, and driving it down a road and seeing how much energy it actually uses. We have found that Jouley, under those average conditions, consumes that much, 1.474 kilowatt hours of energy every mile it travels. Well, by putting that into a short formula, you divide that into 204, it says the usable range should be 138 miles. Are you going to get that? Well, it depends. If you put Joe in there driving this, who's the worst driver in your fleet, and he never gets the average fleet fuel consumption, he's not going to get 138 miles. If you put Jack in there, who's the best driver you got, he's going to get close to this. But again, other factors are going to affect this. Temperature, road, terrain, lots of things affect the temperature. This is a number you can relate to and compare against. And this is a number you can shoot to. Are you going to get it every day? No, but you're going to get close. This is probably a better example of a battery electric vehicle, school bus. Day operation with overnight charging and midday recharging. Jouley is designed for the 50 to 85 miles a day run. That's its purpose in life. Until we can get larger batteries, which aren't available at this point, that's where we are. So we've got a bus that we've taken off the charger in the morning. We drive our 35 to 50 miles. We charge it for a few more hours midday. We do the afternoon run and plug it back in when we get back in the yard. And this bus will run very happily forever and ever. And you will never have a problem with it because it's just what it's designed to be used for. Now, if you've got that BOSI's run or special need run that's 110 miles in the morning and 115 in the afternoon, use one of the other buses because this isn't going to do it. We are limited in our application at this point because of the size of batteries that are commercially available. Now, speaking of batteries, we've got to charge the battery. And there's a number of good suppliers out there of battery chargers for these systems. This is actually the first step. If you're looking at going to electric vehicles, you want to start with your chargers, because the chargers and having the capability of bringing the electric to the chargers and where the charger is going to be placed is a really key decision to make before you go to the next step and actually look at the buses themselves. Now, to charge the bus, you've got to plug in the charger. This is the only connector we can use. It's the J1772 CCS Type 1 combo connector or DC fast charging system. And this is a very common connector in North America. It's a very common package. It does have a catch and a release. So when you plug this in, it locks into the position. And when installed, it will lock in place all by itself. There's a secondary lock which engages internally. Now, plugging this in, the two systems, the charger and the bus, actually talk to each other. They discuss the state of charge of the bus and the capability of the charger to replenish it. And it actually takes a second or two for this to actually start recharging. But when it does, this green light's going to come on. By the way, ignition key is typically removed in this case. We at one time had a situation where you had to have the key on for charging. That was an early discussion, and that was since changed. In fact, some of the old manuals actually still say you have to charge the bus with the key on. The key can be removed now. Now, the charge indicator light, when it does start charging, you'll see this light flashing. When it receives a full charge, the green light will be on steady. Now we have to remove the charger. To remove the charger, you can't just unplug it because there's a secondary lock here to prevent you from trying to remove this while you are charging. Hit the stop charge button. What's going to happen is the system will go through a shutdown to stop the charging process. When that is achieved, this light will start flashing rapidly, and you should audibly hear a click as the secondary lock releases. You can then push the connector release button and remove this and place it back in the charger. Now, there is another light, the red light. The red light is a charging error light. All EVs have these lights and the same system, by the way. The charging error light occurs if when this was first plugged in, these two systems, for some reason or another, could not communicate, and they could not establish the charge rate. If that happens, this won't charge. So what you have to do is hit the stop charge button, remove this, replace this into the charger, and wait 2 minutes and try it a second time. If this light comes on the second time, you're going to have to call someone. There is a problem with the charging system, must be rectified. Now, we got the charger plugged in. How long will it take to charge the battery? And this is the conventional method that has been used for years of doing that, saying what size is your battery? Your battery is 204 kilowatt hours. The charger is a 75 kW charger, which is a pretty darn good size charger. How you find how long it's going to take to charge, you take 204 divided by 75, and it says you're going to charge this thing in less than 3 hours. And folks, that doesn't work. That cannot work. And the reason it cannot work is the charger doesn't set the rate of charge, the bus does. And the bus will not allow the charger to overcharge or overheat the batteries or other components. Think about it like this. I've got a coffee cup sitting on my desk. I want to fill it. So I go get the coffee pot. And I want to do this as fast as I can, just to see how fast I can do this. I want to fill it right to the brim, but I don't want it to spill. Well, you can take the coffee pot and you can fill that pot about 3/4 to 80% full at pretty damn fast rate. But then you have to slow down because I don't want to spill. I don't want to overfill it. I don't want to overcharge it. In fact, as you fill it more and more and get closer and closer to the top, it slows down. You have to slow down even more because you can't spill. That's exactly what happens with a charger. Unless you had something as low as a 25 kW charger that would charge right along at about this point here all the way to the end, you will see this. You will see the charger. This is a 50 kW. It started charging only at 40, and over the period of time, up to about 80% of state of charge, it finally got up to 50 kW. And then it did what? It dropped down to the low 20s. It's slowing down because it can't overcharge the system. In fact, that charge rate even slows down more when we get up around 95%. It slows right down. This is a 175 kW charger. This is an impressive charger. That one started at 61. and went up to almost 70 and then did exactly the same thing, dropped right down to here and continued out at a lower rate and then even dropped more at the very end. This additional time from here to here could be 1 to 2+ hours more to fill up the batteries. Now, another interesting point here, this is 175 kW. Why did we start at 60? Jouley, our bus, the maximum charge rate you can charge is at 90 kilowatts. Doesn't matter what the charger is. It will accept no more than 90. In fact, it usually won't take that. Why is 90 a magic number? Because at 91 kilowatts, you start melting cables. There is so much energy throwing through those cables at 91 kilowatts that we are damaging the bus. Right now, there's a lot of research being done on by a whole bunch of companies to how do we cool the cables so we can increase the charge rate on these batteries. That is a situation which is honest. Now, another thing which is honest here is normally you would never start charging down here. Usually you're stopping the day's run, you're at 25 or somewhere in that range, and you're just charging from here to here. If you got down this low for a charge rate, you'd have one thing on the dash, the turtle would be on. You're at a very low state of charge, and it doesn't like to be down here. This is dangerous. This is an honest statement from Thomas Bus. If you have an output of at least 60 kW, you can get your nominal charge, this charge, in 2 to 3 hours. A full charge in 4 to 6. And that's an honest statement and something that's workable. Now, more important than any of that is training. Currently, DTNA, Daimler Truck, has a high voltage safety training that falls into 3 categories. We have HV1, HV2, and HV3. HV1, HV2, we are qualified to teach you. HV3 is a factory training only. HV1, by the way, is a 1-hour program, basically. HV2 is 2 more hours. This is 3 days. And depending on the specific task and role the user has, he may have to have certain levels of training. Now, the driver of an HV vehicle, unless he's charging the vehicle, he would then have to be trained to charge it, requires no additional training. However, technicians working in your garage, if there's a high voltage vehicle in your garage, everyone has to go through HV1, and we can perform that training for you. That is an awareness program. This is an electric bus. This is how you have to maintain it. This is what you can do, what you cannot do. Very important program. My salesmen are qualified in HV1. Every service tech in our facility, service writer in our facility is HV1. Now, if you're already working on the bus normally and you want to work on an electric bus, you can work on the non-high voltage components if you're HV2. This is the normal tech. And I'm going to explain a little bit more about this in a second. HV3 is working on the high voltage components. The most important part of that is what they call decommissioning and commissioning. Decommissioning and commissioning is where we physically remove the connections between the battery packs and the bus itself. And currently, that is not available for fleet and customer techs. That is only factory and dealer personnel. And that is the current status. So HV3, you're not allowed to get into it at this point. Now, HV2, what can you do? You can service any of the systems of the bus that are not part of the high voltage system. If it ain't orange, you can work on it. You can work on the brakes, the air system. However, remember, the air compressor is now high voltage. So you can work on the air system after the compressor outlet. Any low voltage controls, et cetera, is allowed. If you need to dismount or move a high voltage component, you can't do it. If you're tasked like you're welding near close by, Can't do that. It has to be decommissioned first. However, if that HV3 tech shows up at your facility to work on the high voltage components, he is allowed to permit someone to assist him that is HV2, but they can't touch orange. That's the key factor. Can't touch orange. Now, disabling is something else. Disabling is to remove a bus from service. My salesmen, when they go to a show, have to disable the vehicle that we're showing. This is how you do it safely. Number one, you turn off and remove the ignition switch, the ignition key, from the switch. Number two, I'm going to go to the battery box door, reach inside, and turn the low battery cutoff switch to off. Number three, you open the hood. There's the high voltage disconnect or high voltage junction box on the right front corner of the bus. On the front of that's a high voltage disconnect switch. You turn the switch off. Now, both of these switches have provision for a padlock or a tag or something to go through them, so they can't just be turned back on. That's called lockout tagout, and it must be followed in these cases. Now, how well does the manufacturer feel this product is? That's subject in the warranty. The warranty shows what they feel good about. The standard body and chassis has the same warranty as our other C2s. The Proterra batteries have an 8-year warranty on them. The driveline has a 5-year warranty on them, and you can get extended warranties up to 12 years on this package as we go down the road. This has been a good package for us. Now, that's the end of my discussion. If you have questions or concerns, there's my name. That is the phone number of Matthews Buses. I'm extension 302. My cell number is here. You can text or call me on that. And there is my email address. Now, if you can't get a hold of me, you can call Henry. Henry is our other trainer and our technical support individual. Same phone number, different extension. He has a different cell number. And his email address is a little bit longer than mine. And Dan, that's what I have.
Okay. Well, does anybody have any questions for Roger? Just offhand, anything simple, quick. I just had a quick question here. Can one charger charge more than one bus?
Yes. But you have so much kilowatts in the charger. If you've got a 75 kW charger, you could charge 3 buses at 25 kilowatts each. But you've only got so much. But you can do multiples, and that's a normal process that's used. Henry, can you offer anything on that one? Got to unmute first, Henry.
There are charging stations that you can charge up to 4 buses, but they're at a higher kilowatt rating. So depending on how large, like Roger said, if you get a larger kilowatt charger, you can charge up to 4 buses with, split it up 4 ways. So if you got a 100 kilowatt charger, it's going to be 25, per each bus. Or if you've got a 200 kilowatt, it'll be 50 for each bus.
Another example of that would be there's a Moravito gas station down the road, just 2 miles from my house. And I went over and took a look at, they had chargers there. The chargers are 350 kilowatt. Now, why do they have 350 kilowatt? Because they got 8 stations, 8 plugs on that package. And with that much kilowatts, they can supply an equal amount to each particular vehicle being charged. But it's not designed to charge 350 kilowatts into a vehicle. That's the available kilowatts they have for those connectors to supply multiple vehicles at the same time.
All right. And you said it's 400-volt system?
Yep.
On the bus?
Yep.
And the Cascadia, the tractor, is a 700-volt system?
Yeah.
So would there be a possibility of later down the road increasing the voltage for a school bus?
The reason that voltage goes, why we use a higher voltage is it reduces the amperage. The same kilowatts goes through at less amps. And that's an advantage. If we didn't do that, the cable size gets so large you couldn't carry the cables. You could run an electric vehicle at 12 volt, but the cables would be 6 inches across to carry the amperage load. It's crazy, but higher the voltage, we're seeing more and more operations going to higher voltage operations because it requires less cables, less diameter cables. You carry the same amount of kilowatts, but at a lower amperage.
And Thomas Bus did say that the 1,000-volt bus is coming in the future.
All right. Does anybody else have any questions? Those were the only questions that I had.
Hey, what's the life expectancy on the batteries now?
Right now, the warranty is 8 years. We anticipate they'll go longer than that. Now, the interesting part of that is why a battery would be replaced is we would eventually get to the point where we couldn't recharge it enough to use it in a vehicle. But there is a market for used batteries because they're perfectly good batteries. They just can't hold as much kilowatts as they originally were designed for. And there's a market right now. In fact, the utility companies are looking at putting in battery units to help supplement their loads. And the used battery market is a big deal. But that's years off. That also means there's a value to that battery. You could probably sell it.
Hey, I've been reading that they've been having to spec different tires on some of the tractors and stuff because of the different torque with the motors and the battery powered vehicles. Is that going to happen on the buses too, or can we still use the same tires we've been using?
All the same tires. There's been no indication there at all. The drive lines are just regular drive lines, regular rear axles.
If you were going to go to electric buses, how long does it take to get the charging station? When should you order your charging station? Like a year
before you order the buses.
Yeah, no, but like a year before, or
it's going to depend on the manufacturer, their lead time. They're gearing up right now to provide more chargers faster. We're just ordering some chargers for ourselves, and our lead time is, Henry, what was it?
I think John said it was going to be sometime in like 6 months from now before we'll be getting our charger.
Yeah.
Great. Any other questions? All right.
Hold on a second, Daniel. Has anything been put out as cost per mile compared fuel-wise between this and like your DD5?
Yes. When you look at the numbers, and it takes a little calculation to do it, these things are running a half or third of the cost per mile. The bottom line is you can get from here to there for a lot less money. Now, the initial investment's higher. There's no way around that. But the cost per mile on an electric vehicle is ridiculously cheap. 1.474 per mile at 9 cents a kilowatt hour. We're traveling a mile for 15 cents. And that's cheap. You look at a diesel, you're talking 30 cents.
I mean, how's it gonna figure in when we keep our buses 10 to 12 years, and now you tell me the battery is guaranteed for 8. So how's it gonna figure out when we're at the end of the lifespan of the bus? Because I gotta look at the whole package. You know what I mean?
Mm-hmm. Absolutely. That's where our sales representatives are the experts to talk to.
And then would that battery be prorated, or would it be a replacement battery?
I haven't a clue at this time, Dan.
Yeah, yeah. So probably a little early to be jumping into this.
Well, it's like you wear out one of these diesels, it's a 20 grand right there. You know, or forget to tighten the clamps on the air cleaner, that's $20,000. You know, everything costs money someplace.
Right. All right. Does anybody else have any other questions? You know, this is going to be posted to the website, or the YouTube channel, so you can go back to this and get his name and number and email address, and definitely ask away questions to Roger, and he'll get back to you.
Yeah, please call.
And do they have an electric Minotaur yet, or no?
No. Will they? Probably.
I mean, because like in our operation, a Minotaur we'd be able to use an electric Minotaur before we would a big bus. We put a lot of miles on our big buses, and it's just the way the configuration of our school district.
Yeah, well, that's GM, and that chassis is completely General Motors. That's up to them as to when they want to release that.
Okay. Well, I want to thank you, Roger, for your presentation. I thought it was very informative. As electric buses are entering our, I think it's definitely great knowledge that we're getting from this. I want to let everybody know that you can start sending your nominations for the ASE Master School Bus Certification to, we're going to send them to George Giel, and I'm going to send out an email so that everybody can have it in writing where to send it to. We're going to do 2 people per year, 1 person per district. So if your district has 6 employees, 6 mechanics, we're only going to, we only want you to submit 1 person, or you could submit 2, but we're only going to select 1 per district. But I'm going to put this all.
No, they can't submit 2. They can only submit 1 per district. That's all we're going to take is one person per district. Pick your best. The ones
Right.
that stay with you.
Right. It's going to be 1 per district. So, and I'm going to, like I said, I'll put that all in an email and send it out to everyone. Our summer seminar is still scheduled at the On Center in Syracuse on July 21st, 2022. As of right now, it is still going to be in person. It's still going to be a go. Isn't that correct, Peter? And
that is correct as of right now. We're still
okay. So we're going to go with that. There will be more information on this as we get closer. We're starting to work on putting it together now. Let's see. But before we close, I want to say we definitely are looking for a treasurer. I know I said at the beginning. Definitely keep that in mind. Our next meeting is going to be held on January 12th. Our presenter is going to be Cody Shamrock with Leonard Bus Sales, and he's going to be presenting on the DPF systems and after treatment. So that being said, does anybody have anything else to add to the meeting? If not, I want to wish everyone a Merry Christmas, a Happy New Year, and we will pick up in the new year, in January. All right, at this time, I'm going to close the meeting.
Okay, just one more thing. You'll start seeing the paperwork for mechanics and vendors early January. We'll start working on that, as Dan said, and we'll get the information out, costs, and all the paperwork. So be looking for that after January. And any questions, give me a jingle, and I'll help you out. All right. Merry Christmas, everybody. Happy New Year.
Okay, same to you.
Christmas.
All right.
All right. Thank